The probability that event B occurs given that event A has occurred is called the conditional probability of B given A. So it's written as probability of B given A. So you're not finding the probability of two events happening. You're finding the probability of one event happening given something else has already been done or taken place. So the table shows the results of a class survey of 28 students, and it asks, did you do a household chore last night? So it says, for number one, find the probability of a student doing a chore. So that is not a conditional event. It just says, okay, how many kids did a chore? So if they ask 28 students, the ones that did a chore are the ones that are yes. So that would be 14 out of 28, or 1/2. Or 50%. Again, whatever you guys write it as. Okay, so find the probability of a student doing a chore given that the student was male. So this is kind of the total that we're looking at. So given that they were male, so out of the 15 males, what's the probability that they did a chore? 7. So 7 out of 15. Find the probability of a student not doing a chore, given that the student was female. So again, out of the females then, there's 13 females. Probability that they did not do a chore is 6 out of 13. So you're finding the probability of one thing, but it's given something else. So there's sort of like a protocol there, or a guideline. So there is a formula for conditional probability. The probability of event A given, or the probability of B given A, is the probability of both of them happening over or divided by just the event of the first one. So the probability of both divided by the probability of the first thing happening. So in problem 3, which we did here, it asked us to find the probability of a student not doing a chore given that they were female. So the probability of A were the females. So that was the 13 out of 28. Probability of B not doing a chore was 8 and 16, so that was 14 out of 28. Probability of them both are 6. The 6 no chore females. So if you guys put that into the formula, the probability of A and B on the top is the 6 out of 28 divided by the probability of the first event happening. The probability that it was a girl is 13 out of 28. So what would happen is if you guys divided them, you would have 16 or 6 over 28 multiplied by 28 over 13. I'm just showing you how it works. And what happens is they cancel whenever the denominators are the same. So you just end up with 6 out of 13, which was our response. So there is a formula there for you to use. It's the probability of both things happening divided by the first event. So I'm just going to do one with you to kind of give you an idea. So let's go ahead and look at number 5. What is the probability that the sum of 2 die? So what's the probability that the sum will be greater than 8 given that the first die is a 6 or rolls a 6? Okay. So the probability of the first goes in the bottom. So I'm going to write it out in words first. So probability of a 6 is the first event. And then the probability, let me write P, probability that you roll a 6 first and you get a number that gives you a sum greater than 8. So if you rolled a 6, what numbers would you need to get a sum greater than 8? So a sum of 9, 10, 11, or 12. So 6 plus 3, 4, 5, or 6. So the probability of a 6 and then a 3, 4, 5, or 6 on the second one. So now let's do it with numbers. So the probability of a 6 is 1 out of 6 times a 3, 4, 5, or 6 on the second one is 4 out of 6. And we said the probability of a 6 on that first thing is 1/6. So what happens is these guys kind of cancel out, and we're left with 4/6 or 2/3. Is the probability of rolling a 6 first and then getting a number to get a sum greater than 6 on that second die. Okay, go ahead and give that practice assignment a try for conditional probability.